So this will be by way of recap. So today will be the final class in terms of the growth model. We started, I believe, from chapter 6 up until chapter 8, which contains all the growth models that we are supposed to, or I believe chapter 7 or so, so chapter 8. So we started by looking at the Malthusian and trying to explain growth. We realized that Malthusian was very good in trying to explain one or two things, and it was a very old model, if you quite recall. And as part of our factors of production, we had Z, we had F, and here we had N. But in terms of the difference, when you compare to this modern age, instead of having capital, we rather use what we call land. And because land was bounded, there were a couple of issues that came out of it. So we realized that standard of living wouldn't increase over time because of the fact that the population increase will outdo the increment in the output. We also realize the fact that we have unbounded growth in terms of the production due to land being fixed. So this has this whole idea of unbounded growth in that respect. And other factors that I think we all explained and we found interesting. So given the limitation that the Malthusian had, and given the fact that it wasn't able to explain one or two things that we saw in the data, we had to move away from the Malthusian to what's called the solo growth model. So we move away from the Malthusian to the solo model, and what we realized under the solo model was that instead of the usual production function that the Malthusian had, we first of all have to change it a bit and include the fact that there is a land playing a role. Sorry, capital playing a role instead of land. And we also had investment playing a role and all that. So this, again, by using the solo model, we were able to explain some, good empirical observation in terms of the data. We were able to explain why standard of living will increase over time, which the Malthusian wasn't able to help us explain. We're also able to see the differences in income over time and a couple of predictions that the solo growth model gave us, just like what we saw on Tuesday. One limitation here is the fact that it's always predicted that there's going to be what we call convergence. That is, the poorer countries will catch up with the richer countries. So given the fact that they all have the same N, they all have the same D, and they all have the same Z, then the prediction is that there's going to be convergence over time. This idea of convergence in data is very hard to see. One part of it, we can observe it, which is between richer countries. Richer countries tend to slow down a bit. However, in trying to compare rich countries to poorer countries, it's very hard to see this whole idea of convergence that the solo model predicted. So that happens to be one limitation in trying to see the difference between rich and poor countries. The second important aspect here, when we talk about the limitation of the solo model, is the fact that we don't necessarily know how this efficiency comes about. We don't know how our decisions tend to affect this efficiency. Basically, this is just an exogenous variable given to us in the solo model, and we just had to work with it. There's nothing like, hey, this decision leads to this Z increase, or this decision leads to this Z decrease in the model. So we weren't able to find it. It was exogenously given, and it didn't make it interesting as we hope to find. So these limitations, in terms of the Z being exogenous and in terms of the convergence not being realistic when we compare the rich countries to the poor countries, we then have to move away from the solo model to something that might be pretty much realistic. So 1 and 2, these two limitations in the solo model will lead us to go to a new model, which is the endogenous growth model. And with the endogenous, yeah?
We just have a question. Alex was asking, is it because the countries can hardly have the same N, Z, and D, so we cannot see the convergence?
Sorry, your line was breaking a bit. Can you mind?
Sorry. So, because you said the assumption is that the same N, Z, and D for the convergence to exist. So is the reason we don't actually see this because that it's not, those aren't the same across poor and rich countries?
Yeah, that would be a very good argument if you want to argue for if you want to argue for Solo, right? So what we saw on Tuesday, we had two specific assumptions. First of all, the assumptions that we made was the N being the same for the rich and the poor countries, the Z being the same for rich and poor countries, and I believe the S being the same for rich and poor countries. There, we saw that the prediction of Solo was that there's going to be convergence. However, we went a step further to say, hey, when we are to relax these assumptions that these guys are the same, what will be the prediction of Solo? There we saw that Solo was good in predicting these differences over time. So it all has to do with the assumptions. If I say that Solo believe that everybody has the same N, everybody has the same S, and everybody has the same Z, then Solo wouldn't be a good indication as to how the rich and poor countries do perform over time. But if you are to say that this is not the assumption under Solo, then you can have a good prediction under Solo. So it depends on where you are looking at it from. Did that answer your question?
Yeah, that makes sense. Thanks.
Yeah. So we should just keep an eye on those assumptions, because it's, as I said from last week, I might come back and ask you guys. Just to reiterate what we saw from last week, back to LS question. This was the question that we had. So if you guys remember, we had this guy here, we had this guy here, we had N plus D here, we had S of Y here, we had K star here, we had Y, and then we had I here. And I believe Alex corrected me the last time that we need to get a third line which captures the fact that this is an output, which I agree with him. So, but for the sake of time, I just drew one line to make things easier. But for you to be concrete enough, you need to get the third line here. So this is the point where we had K star, if you quite remember, which is the steady state value. And this here, as Alex pointed out rightly, this is going to be our Y star and not this guy. With this diagram, what I believe I'm trying to point out at the same time here is that the rich country has the same N as the poor country. The rich country has the same savings rate as the poor country. And the rich country has the same Z as the poor country. If they have the same thing, and again, I think we didn't capture the fact that they might also have the same D, because D is very important, right? You have the same D as a rich and poor country. So if you have this assumption that everything is the same, then what Solo predicts here is that the growth rate of the rich country, given the fact that they are more towards the steady state, will be different from the growth rate of the poor country, which is a bit far from the steady state. So the poor will grow at a faster rate. The growth rate of the poor country will be greater than the growth rate of the rich country. This is the prediction by Solo, if everything is the same.
I just have one more question.
Yeah.
So the main goal of the endogenous growth model isn't to explain convergence, but to explain growth as part of the model, because you can change those assumptions and get a more realistic outcome.
Exactly. Yeah. First of all, it tries as much as possible to do away with this prediction. Even if they are to have the same everything, it is trying as much as possible to tell us that, hey, one will continuously grow. Provided you take the lead, you forever take the lead. Nobody will catch up with you. Unlike Solo, that says that if everything is the same and the rich country takes the lead in terms of capital accumulation, the poor country will catch up. That's one outcome under Solo. What we are going to do today in terms of the endogenous growth is, regardless of we having the same thing, as soon as I take the lead as a rich country, I'm forever going to take the lead, and my growth rate is going to be higher than yours, or the rate at which I grow is going to be higher than yours. Is that okay?
Yes, that's good.
Yeah. So this is what we saw from Solo. Everything here, this is the assumption. Now back to what you asked earlier. If the n is not the same, if I'm to have different n's, then this line will be different and I have different prediction. And Solo will be consistent with data. If this s is not the same, then I have different lines for the concavity, and Solo will have a different prediction which might be consistent with data. If z is not the same thing, Solo might be consistent. So that's the whole idea. So just keep an eye on the assumption as to whether they are the same or not, and what will be the outcome under Solo. Is that okay? Is there anyone with any question in there?
No more questions.
Good. Now, one thing I would like to ask the class is, if you probably have read before coming, then it might be easier to understand Solo's argument. What will be one key factor under Z not being the same? What might contribute to the fact that the Z and the rich country might not be the same for the Z and the poor country? Is there anyone to help us? So here we are, yeah, Z is technology. What will be the reason why the Z in the poor country might not be the same as the Z in the rich country? Exactly.
Resources available.
Resources. Can you read John's question and I'll come back to the resources?
Presence, absence of corruption.
Exactly. That will be one important factor. The corruption rate might prevent people from implementing ideas that will help grow the economy. So it will lead to inefficiency, right? So John has a very good point there. I saw R&D. Again, corruption will, so for instance, if I live in my part of the country where corruption is very rampant, if someone is to contribute maybe $1 million into having a new idea in getting things done, I might pocket 90% of the money in my pocket and wouldn't see any improvement in my country. Because of corruption, Z is not going to increase, and for sure, they wouldn't be the same between the poor and the rich countries. So I think I saw R&D, I saw corruption. So these are things that you should just keep an eye on as we go along. Is that okay with everyone? Ella, is there any further points raised in there that you think we should analyze?
Alex says ideas. And we also have.
Yeah, feel free.
Oh, the one more is inefficiency and allocation of inputs.
Yeah, inefficiency and allocation of inputs might be related to corruption, as you guys pointed out. Yeah. Ideas might be restricted because ideas are the same as Z, which is efficiency. So what you are trying to point out here is how different is the implementation of Z in rich country different from the implementation of Z in the poor country. So just keep an eye on that, okay? One thing here is, what might be your argument as to why you think the N in the rich country might not be the same as the N in the poor country? Anyone with any idea in there? Policy? Yeah, which policy? Policy is general. Ella, is there anyone with any idea in there? I saw policy, but I don't know which.
Population growth decreases as countries develop.
Exactly. That might be a very good point, right?
Yeah.
The reason why we might not see the same population growth between the poor and rich country might be that in a country like, if you want to go with Malthusian's argument, in a country like USA, where the economic growth is very high, you see women participating in the economic sector, and they would like to get lesser and lesser kids. Compared to where I come from, where the economic activity is not that much, and women have lesser opportunities in terms of the economic activity, then they are most likely to stay at home and the outcome of it might be giving birth to a lot of kids. So that's a good point there, Alex. Yeah. Anyone with any further points?
Population growth policy.
Yeah, that's what. Yeah. That might be a point as well. Yeah. Further points?
This is just my thought. Could it also be like malnutrition and like
exactly, which will go the opposite way, right? It will go the opposite of what I just pointed out in terms of the economic growth. So if I understand malnutrition in a country like Africa, where we have higher malnutrition, the mortality rate is going to be very high. And with a higher mortality rate, the birth rate is going to go down, right? So we have poor countries having lesser kids. Whilst in a rich country like US or Canada, where you have higher nutrition, then the mortality rate is going to be extremely low, and then we have higher growth rate. Is that your line of thought, Ella?
Yeah, that was it. So we have a few more here.
Good.
Culture.
Yeah, culture might be. So from the part of the world where I come from, be giving birth to maybe 1 or 2 is frowned upon. You need to give birth as much as you can. So 10 is the best that you can do, or maybe 12, or maybe 20, or maybe 30. But in this part of the world, the culture is that 1 or 2 is fine. So that might be a good point there. Yeah.
Mm-hmm. And then also difference in healthcare.
Exactly. I think that's what you pointed out. It falls under nutrition that you pointed out earlier. Yeah.
Mm-hmm.
Further points?
The last one is living environment.
What's that?
Living environment.
Yeah. Living environment might be part of it. Yeah. Is that okay?
Mm-hmm.
Now this parameter we've not talked about, which is D, and it appears here. So it means it's also very important. The question here is, what do we think might contribute to countries having different D? Why is it that there might be a different D for a rich country compared to poor country? Remember, D represents depreciation. Anyone to help us? Why do we think there might be different rates in terms of D?
Instability, civil strife.
What's that?
Instability, civil strife, and we also have war destroying capital.
I don't know whether you guys can explain it a bit further. It's pretty much short.
I think like the destruction of capital through like it being destroyed by people, like war, conflict.
That's a good point, but I don't know whether I should take it as part of a shock, a different shock, or I should take it as part of depreciation. If you buy a computer, over time it becomes slow. It doesn't become slow because you think there's going to be a war or there's going to be a disaster that might strike, but it's just going to become slow because of your lack of maintenance culture, right? Mm-hmm. So if you lack the whole idea of, hey, I need to clean up my computer each and every day, or I need to update my software each and every hour and all that. So if you have that, if you don't have a very good maintenance culture, then your assets will depreciate. But in terms of war, it's something that you don't have any control over. So you might want to take it as a shock rather than as a D, right?
Sure.
Even though I would take it as part of your answers. I'll give you the full mark. But just, yeah. Any further points there?
Yeah, there's a few. I can just read through them. So we have weather conditions, unemployment, not enough skill to employ it, quality of the capital in the first place, and that's, yeah.
I would take the weather condition as the most important one, and that's a perfect idea because this is a rich country and this is a poor country. It might be the fact that you all use the same computer, the same model and all that, or the same tractor. But in the poor country, the weather is very bad. compared to a rich country, which will just depreciate your equipment right away. So that's a good point. Yeah, weather. So here, even though this D is a parameter, you might want to make it as a function of maybe weather, maybe attitude, one's attitude, etc. And see how these factors will affect it. So when weather becomes bad, what happens to D? When your maintenance culture is very good, what happens to your depreciation and all that? So an example here is when you have a very good attitude, when your attitude goes up, the depreciation rate goes down because you are very good with maintaining what you have. Any further questions in there? So these are the yeah, feel free.
James, I'm not sure what he's saying. Wouldn't that be lack of S? Are you talking about depreciation or something else? Oh, okay. I think that was nothing, but we have, what about altitude?
Altitude might be the same as weather in a way because they have the same field, right? So is it attitude or altitude? Sorry.
Altitude.
Altitude might be the same as the weather, right? Because if you're on a different latitude and then longitude, you might be, exposed to different weather condition compared to somebody with different longitude and then, yeah.
Oh, I think she was just confused. It says attitude on the board. Yeah.
Attitude is your maintenance culture. If you're somebody who has a very good attitude, you have a very good maintenance culture. Every time you use your equipment, you are very conscious. You go in and clean it up and all that. So that means a very good attitude towards your kit or your equipment. And with that, your equipment wouldn't depreciate very fast. It will take some time to, right? Is that okay, Osama?
Yes, that's all good.
Okay. Good. So this is all what we have under the solo model. So as you prepare for the midterm, even though these are parameters that have been given to you exogenously, you also have to think about it as to what are the factors that affect them, just like what we just finished doing. And hopefully things might be much easier. So I'm done with the solo model, and we need to move to a new model that tries to resolve the issues that we had with solo, and that's the endogenous model. So with the endogenous model, there are two things that we are very key about. We are moving away from the exogeneity of growth. Now, this question is to the class. In the solo model, what determined the growth rate of our output, consumption, investment, and all that? What determined it? Anyone to help us? Exactly. Population growth. Good. So we are going to move away from this fact that this exogenous end, which determine our growth rate and everything, to a more endogenous feel of it. We're also going to move away from the convergence idea. As I pointed out, convergence basically means that first order condition is increasing and it increases as an increasing rate. So these are the two things that we just have to keep an eye on. See how the endogenous model takes away this, see how it takes away convergence, and see how it better explains the data compared to solo. So just keep an eye on that and make sure you stop me if there's any question. So we are going to grow in a very unique fashion. We have a model that helps explain what's going on. So if you are to pay attention to chapter 4, I believe, then what I'm going to derive here is going to be very easy. And if you happen to forget and you need further clarification, just let me know. First of all, I'll start by looking at the factors of production. Under solo, before we produce anything at all, we had Z as a function of, and under endogenous model, we're going to move away from sorry, the board is a bit. So we have endogenous model. We produce using a different approach. So Z as a function of, I'm just going to put H here. I'm going to put K here. The difference here is that here we have capital, and this capital is what we call physical capital. Whilst under the endogenous model, we have what we call human capital. So it's going to be capital, which is H, but it's going to be human capital. This is the very first key difference between the endogenous model and then the exogenous model. In the exogenous model, which is a solo model, our capital has been given to us. However, the capital is physical. And a couple of properties that come with physical stuff, like computers, like tractors, like you name it, is that their return to output is diminishing. So the more capital you have, the better. However, for every unit that you add, it increases at a decreasing rate. So this implies that there is a unique property here, which is the diminishing marginal returns of capital, which I call DMR. Due to this property of diminishing marginal returns, we have our outputs to look like this. Our output increases for sure, but it increases at a decreasing rate. So capital returns to output, it increases, but at a decreasing rate. That's the first property that comes with fiscal capital. And also, we call it rivalry. Having one prevents the other. In terms of the human capital, there is not going to be diminishing returns to scale. No, we might have a constant returns to scale. That is to say, for every new idea that you have, the economy is going to grow. And it's not limited in terms of it diminishing. So if I have an idea, it doesn't prevent the next person from having a better idea or probably the same idea and using the idea in producing that something that is equally good. So there's not diminishing returns to output. It might look like a straight line, but for sure, it is not going to decrease over time. So these are the two key differences between the exogenous model in terms of how we get returns to output. You have a question?
Yeah, can returns be increasing for human capital?
It might be increasing. It might, yeah. Yeah. But for the sake of simplicity, I believe we have B to be equal to 1 or greater than 1 for now to make things easier, but you might have an increase in returns as well. So here in the solo, this guy is diminishing. In the endogenous growth model, we have a human capital that is not diminishing. It has either increasing returns to scale or constant returns to scale. And because of that, what we saw here is that if I have an economy wherever I increase my K, my output increases, but it increases at a decreasing rate, what we have here is we have boundedness. And by boundedness, I mean we have a limit against which we cannot go over because it's diminishing returns. So if I live in a space that can accommodate maybe 10 tractors and I have 12 tractors, I cannot do more than I could have done when I had 10 tractors. And that's the whole idea. Yeah, when the marginal...
Is the maximum NPK equals 0?
Yeah, the marginal returns of it being 0. But sometimes when you go deeper into economics, you might come across someone having a negative return as well. Is that okay? So if you did 103, you might have the marginal returns to labor being negative. All right?
Okay.
Yep. So that's the whole idea. So there's a boundary against which we cannot go over.
Can
Alex?
you just explain again? You just mentioned solo has diminishing marginal returns, but endogenous has CRS or IRS. I remembered solo has CRS, isn't it?
Solo has diminishing marginal returns, right? So capital. For every capital that you have.
Oh, constant returns to scale. Doesn't solo have constant returns to scale?
Yes, that's a good point. Let me quickly point out. So what I'm trying to point out here is that there is diminishing marginal returns to capital. For every increment in capital that you put in, it gives you a rate, but at a decreasing rate. That's perfect. So what Alex is pointing out with regards to the CRS, the constant returns to scale and all that, I think I should have been very specific with that, is when I increase capital and labor with the same amount, then I have the same output here. So what he's trying to point out here is with the CRS, constant returns to scale, when I increase this guy with the A and I increase this guy with the A, then I have an additional A here. So that's constant returns to scale. So it might be a mistake based on terminology, okay? That's constant returns to scale. What I'm trying to point out here is the marginal returns to output for capital in terms of K. So that's what I mean by diminishing marginal returns. For the case of human capital, I should have said an increasing marginal returns to human capital or constant marginal returns to capital. Either should work. Is that okay? So it's just a choice of terminology.
Okay, so we haven't talked about like constant returns to scale in the endogenous growth model yet. We're only talking about marginal returns to capital, human capital.
It's the same because I'll try and show you guys a production function. It's just the same. It doesn't really cause any difference because we have only one factor of production in the endogenous model, which I'll come and look at because it's just H. So when I just increase H with a factor of maybe 3, output will increase with a factor of 3.
Okay, so the endogenous growth model has constant returns to scale as well.
Yeah, it has a constant return to scale as well. If and only if we give it a linear function. Yeah, it should have a constant returns to scale.
Okay, thank you.
Sure. Is that okay with everyone? So this guy is bounded and this guy is unbounded. Okay. So let me quickly point out what we've been doing. And because today we have a lot of time, I will go back and explain what we just finished saying. To those who were confused by it, my bad. So let's see what we have right now. I'm I'm going to show you guys two production functions and see whether we can answer Alex's question. And that was a very good point that he raised over there. A, we have a production function that looks like solo. And for us to produce, we have y equals z f of k n. I'm going to prove the constant returns to scale, which is a CRS. Before we do that, let's assume we have a Cobb-Douglas production function. So y, which is the same as z as a function of f and k, which is the same as z as a function of k to the power alpha and n to the power 1 minus alpha. For you to produce constant returns to scale, what you are saying here is that if you have y as a function of z, as a function of this, as a function of that, as a function of n, if you increase this guy with a c and you increase this guy with a c, the same amount, then output will increase with a factor of c. That's constant returns. When you increase it with the same factor, which is c, output will come out with the same factor of c. Is that okay with everyone? That's constant returns to scale. Now let's see how it plays out here. I have y equals z as a function of k alpha as a function of n 1 minus alpha. If I increase k with a c and I increase n with a c, then I have this guy now becoming, is that okay with everyone? Is that okay? Ella, is anyone with yeah?
No question.
Okay. So this guy is just the same as me saying z multiplied by c to the power alpha, c to the power 1 minus alpha, k to the power alpha, n to the power 1 minus alpha. And this is the same as me saying that this, they have the same power, they have the same base and different powers. So it will just cancel and become c. This is just k to the power alpha, this n to the power 1 minus alpha. I can just change them, put the c before the z. So this guy is now y, because that's the same definition we gave for y, and there is a c in front of it. So that's constant returns to scale. When you increase both factors with the same amount, they will all increase, the output will increase by the same amount, which is c. Is that okay with everyone? That's here. Is that okay? Questions?
No questions.
No question. Good. Now, within the same model, what I'm going to prove here is the property of diminishing marginal returns, specifically to capital. Diminishing marginal returns to capital within the same solo model. Remember, we have the output that looks like this. Y equals z as a function of k alpha and 1 minus alpha. To prove diminishing marginal returns to capital, as I pointed out, you have to tell us that capital increases output in the first place. So the change in output due to changes in capital needs to be positive for you to have the first property. The first order condition should give you this. So when I increase this guy, what will be the derivative of this with respect to y? It's just going to be alpha z K alpha minus 1 and 1 minus alpha. This will be the first order condition when you differentiate it with respect to K. But we already know that alpha falls between 0 and 1. So this guy is positive, already given to us. Z is positive. The amount of capital is positive. This guy is also positive. So the first order condition property has been satisfied. Remember, the first order condition should be greater than 0, and the second order condition should be less than 0. So we are done with the first order condition, which means this guy is greater than 0, which means it's positive. Same under the Solo model, same production function. Let's find the second order derivative. So I'm going to differentiate what I just did right now with respect to K again. And let's see what comes out of it. And again, it needs to be negative for you to satisfy that. Remember, this guy now becomes alpha minus 1. There is already alpha here. There is Z here. There is K here. There is alpha minus. What am I supposed to put there? Alpha minus. Anyone to help me? Anyone? 2. And there is N minus alpha. Now, the good news here is that because this guy is less than 1, this guy is negative, this is positive, this is positive, this is positive, this is positive. So this guy is negative. So the diminishing marginal returns to capital has been proven. Is that okay with everyone? So as Alex pointed out, there's a need for us to differentiate between constant returns to scale and diminishing marginal returns. This is the constant returns to scale property of the Solo model, and this is the diminishing marginal returns to capital property given the same production function. Is that okay with everyone? Any questions?
Looks like it's good. No question.
So if you happen to be in the chat room, just type your full name and type present. John, you have a question? So just type your full name and type present for now. I'll give you guys 30 seconds. I'll come back to John's question.
Would you like me to read out John's question?
John?
Do you want me to read out his question?
Yeah, sure, feel free.
He says, so only the first holds for the endogenous growth model.
Yeah, only the first, only the first holds for the endogenous model if you are given a linear function, yes.
Okay, thank you.
Even if it's not linear, it should be this. It should most likely be the same, given that we are just using H. Is that okay with everyone? If you have questions, let me know. Now, before we go ahead and deal with, so this is Solo. This is the production function. So there is a limit. So finally, if you combine this, and you want to draw what you just finished drawing here, then we have this graph, which shows you the diminishing returns to property, the diminishing returns to capital property. So there's going to be some level of boundedness somewhere. So Solo is bounded in that respect. So there's going to be boundedness in that respect. And because of the boundedness, there's going to be convergence, right? As it's bounded, there's going to be convergence. And that explains what he said earlier, that rich countries will move faster to the poor countries. Now, let me move away and look at a different production function that we have. Some of you are very, very observant, and I actually like that. You should keep it up, especially the likes of Alex, John, and the rest, Osama, and the rest. Please keep an eye on that whenever you realize a mistake or you think something is not clear, just point out so that we can all work around it, right? So I appreciate the help. Now let's try and do the same thing, but for the cases of endogenous growth. So instead of going with solo, I now want to go with the endogenous model, see whether we have constant returns or not. So let's imagine the situation where we have B, which is the endogenous model. Here, output is being produced using, I believe, Z as a function of H. We can give this guy a function that looks like this, Z, and I just gonna put H here. We produce linearly. So if you want to prove CRS, here, which is a constant returns to scale property, multiply this guy with a C, when you multiply H with a C, then this guy should come out clearly. So let's see whether that works. When I multiply this guy with a C, what do I have? I have Z, H. I'm going to multiply the H with a C. I put a C here. This is the same as me saying that C multiplied by Z with an H. And this is Y, which is the same as C multiplied by Y. So this is a constant returns to scale property. Is that okay with everyone? Questions in there? Class, right?
Like it's okay.
Good. Now let's go to the second part of the property, which is whether it is diminishing returns, increasing returns, diminishing returns, diminishing marginal returns, increasing returns, or not. To human capital, right? So we have Y, which is a function of Z, H. First order condition, the Y, the H. What is it going to give us? dy dh, anyone to help me? dy dh, what's it going to be?
Z.
Z, yeah. And Z is positive, so this guy is positive. Now again, differentiate the same thing, the first order condition with H again. What are we going to get? Apart from John, anyone can answer, apart from John. What are we going to get? When you differentiate 0, right? You're just going to get 0. So this is not decreasing, right? So this is not decreasing returns. So here, when you want to draw this graph, it's just going to be increasing at a constant rate. It's going to increase at a constant rate. Is that okay with everyone? Now, coming back to John's question, that is, can it be increasing at an increasing rate? And I said, yes, it can if you use a functional form. An example of the functional form is going to be, imagine putting an alpha here, where your alpha is greater than 1. Imagine putting an alpha there, and your alpha is greater than 1. Your first order condition will therefore be Z alpha H alpha minus 1. Whilst your second order condition will be alpha minus 2. Is that it? H minus 2. Right? Is that it? Is that okay with everyone?
Looks like it's all good.
Okay. So here, this guy is positive. And this guy, because it's greater than 1, it also has to be positive. And this guy is also positive as well. So instead of having a straight line, you have a line that looks like this. It increases at an increasing rate. So that's back to your question, John. It might be increasing at an increasing rate. But in terms of the CRS property, let me put alpha here. When you multiply it by C, you end up with the same CRS, constant returns to scale. So that's one thing we need to keep an eye on. Yeah, but the constant.
But the constant case will be more common, right?
You said?
So the constant case, that will be more common, right?
Yeah, here, when you're talking about here, the constant case will be more common. Yeah. It's very common to see the constant case. Is that okay?
Yes, that's good.
Good. So I would like you guys to quickly take a paper and a pen and write present and try uploading it on Canvas. I indicated attendance 5. Just open your open Canvas, go to week 5 attendance and upload that file. I want to see how easy it will be for us to upload our files during the midterm. So just go there, try uploading a file, and let me see within 5 minutes. Let's see how it works. So just get a pen and a paper. If you don't have one, you can quickly go get one and try uploading it. And let's see whether it works. If it works fine, then we might have to revise how we go ahead with the midterm. Yeah. Anything works, provided you can take a picture, whatever you think you want to use for the midterm, try and upload it. Yeah, so go to Canvas. There's gonna be a portion where I said attendance week 5. Just click on it and upload it there. Okay. If you can't find attendance week 5, let me know. I think it should be there. I checked it this morning. This is just
under assignments as well.
Is that?
If you click on the assignments tab, it's right there.
Yeah, should be there. Yeah, so when you guys are done uploading, you can take 5 minutes break and we can come back at 35 to finish up the endogenous model. So you can take 5 minutes break. Yeah, so as I said, you should upload it on Canvas. It's gonna be on Canvas, attendance week 5, just under the assignment, it should be there. Are we back? So let me know if you guys are back. If is everyone back? Good. So let's quickly good. So let's quickly see whether we can have a sense of what we did. So just a recap. So with John's question, so when you talk about the endogenous growth model, due to the non-diminishing marginal returns to human capital, we have this type of growth. And with this type of growth, it will continue growing in as much as we increase our age. So as we increase age, there's going to be growth. So when you look at this diagram, the implication here is that the endogenous growth model will therefore be unbounded. You are not bounded, like what we saw in solo. So that will be the final indication of the model. You're going to have an unbounded growth. Is it okay with everyone? Is the board clear? Can we see? Hello?
Yes, we can see, and that sounds good.
Okay, good. Now let's quickly move to the endogenous model and try solving it and see where what the implication will be in terms of growth and all that. So to solve for this, you might want to read I believe chapter 4 or so, to get a very good understanding of it, because it's just going to be a competitive equilibrium market where we have individuals and household playing, individuals as well as firms playing the most important role. There's not going to be government. If government comes in, I'll let you know. But for now, we don't have government playing a role here. So what we have here is I have an individual who consumes. So this is his budget constraint, just like what we saw. So everyone's budget constraint is just going to be what you work, the amount of labor that you supplied. If you have leisure, you put it there, and what's not. For the sake of this model, instead of using N, we would like to use H to be consistent with the whole idea of human capital. So we have this guy, C equals this, and this is your entire human capital. But just like what we saw in chapter 4, you don't have the entire 24 hours to work. In chapter 4, we said part of it goes to leisure, whilst the other part goes to work. Here, our assumption will be that a fraction of it goes to work, whilst the other fraction will be in school, trying to get a new knowledge to improve your human capital. So the fraction that goes to work is what we call U, and the fraction that goes to school is what we call 1 minus U. So this is your consumption as a household. So this is your supply. This is how much you supply in terms of efficient human capital, and this is the wage that they pay you. Is that okay with everyone?
Yes.
So with the household, one important thing that we like to point out here is if you've given part of it to work for you to consume, the other part is what you give to school or improvement in your own capacity as a worker or as a human being. So here, 1 minus U goes to the other part of your improvement, and we have H here. So that's the first part. 1 minus U goes to your improvement. But as we saw from the earlier section, your improvement for every time that you spend in school, you don't get it instantaneous, right? So you go to school today, you graduate, and you get work tomorrow. So the improvement or the outcome comes, 1 year after you are done with the investment. So this is what we have, 1 minus U. But one important thing we need to also take into account is the fact that there might be an additional return to you seeking knowledge. So if you go to school and you spend this much time, you get this return for tomorrow, but your community or where you find yourself or how knowledge is being transferred within your vicinity, the efficiency of the knowledge spread is going to be B. So when I live in a very good society where people share knowledge easily, and I know for sure when I go to school, people can share their knowledge with me, then the efficiency is going to be high and my return on education is going to be extremely high as well. Is that okay with everyone?
Can you just repeat what B means?
So B, think of B as an efficiency, right? What should I even say? So imagine I live in a society, right, where everybody encourages you to go to school, compared to a society where people don't really care about school. The idea here is that with a society that encourages knowledge spread, which encourages people to go to school, if you find yourself in that society, the rate at which you improve as a student or as a human being is going to be very, very high. If I have a group studies and all my group members have excellent grades, they are extremely intelligent. The intuition here is that when I spend much time with them, I should have a much higher return myself, compared to me living in a group where the students are very lazy and they don't really care that much. They don't share their knowledge with others. They don't have it in the first place. The return that I will have, it's going to be extremely small. Is that okay? So the B here, yeah, so the B here represents the efficiency, the rate at which the knowledge do spread. Given the fact that you invested this much, you are supposed to get this, but there might be some extra return that your environment will determine. Is that okay with everyone? If you have questions, let me know.
Yeah, Alex is just saying, how can we say like efficiency of applying knowledge or spread knowledge? I think he's just like describing what you can call it.
Is that? Sorry?
Like, is this what we can call the efficiency of applying knowledge or the spread of knowledge?
Yeah, the spread of knowledge, the efficiency of applying knowledge and all that, yeah.
Mm-hmm. And then could you think of B as the Z of HC, like the technology associated with accumulating HC?
Correct, absolutely. And that's why I call it efficiency, because technology itself is efficiency, right? Yeah.
I.e., a country with high-tech, well-equipped universities would have higher B.
Yeah, provided they encourage people to go seek for it the more, yeah. But for now, we just take it as the exogenous. Unless, of course, if we make B as a function of Z, then that's where John's elaboration will come in. But for now, we just take it as B, but we just have to get a general understanding of it.
Okay. Yeah. Okay, thank you.
So we have this guy. We have how the knowledge do spread. So please keep an eye on this equation because it's going to determine a lot of things. So we are done with the household. The next thing we need to do here is to deal with the firm. So as we might have realized from the, can I claim this guy? Yes, sir. Okay. So household is down. Let's go deal with the firm. And given the fact that I solved for the first order condition for the firms, it should be fairly easy to work with. So for the firm, remember the firm produces an output, which is Y.
We've just got some questions from before. So
yeah,
Alex is asking if there should be H's as well in the equation. And so like H prime equals 1 minus B, U times H, or something like that.
In equation, sorry, I couldn't get this. So which equation? Yeah.
Oh, he's saying he typed it wrong. But at the same time, John is saying like HC supplied, that's how it was in the book. Where there's H's within the equation.
Where there is H within the equation.
Can you see the chat? Can you see his equation?
Oh, sorry, let me quickly check it out. So I have H prime, 1 minus U, B. Oh, yeah, labor supply, yeah. So, yeah. So just like the case of the chapter, I believe chapter 4, remember we had to differentiate between labor supply and labor demand, right? I guess that's where you are coming from, right? Was that it? So you wanted me to write this guy as HS, just like what we saw in the textbook, right? Is that it, John? Is that it, John?
I think so. It's Alex that was asking.
Oh yeah.
Yeah.
I decided not to put the S on the labor on the H because I was specifically talking about the household, right? So we don't need it. Provided I wrote household here and I wrote the equations, it basically tells you that it's coming from household. So if you need further notation on the on it, I can surely do that. But it doesn't really matter. Yeah, that's household, right? Yeah. Is that okay? Yeah. That was coming from household. The labor supply is coming from household, and you can decide to put S over there, or you can decide not to if you are clearly talking about household. Notation wouldn't be an issue there. Unless, of course, you are being general. If you are being general, then you have to put the S over there. Was that the question? Is that okay with everyone?
Yeah, I think it's all good.
Okay. So let's talk about the firm. So we are done with the household. Let's talk about the firm. So this is what we have as the firm's decision making. It produces giving H, right? And there's going to be U here. Now, coming back to what John was trying to ask, because I wrote a firm here, I don't necessarily have to come and write the labor demand by the firm. I don't necessarily have to do that. But if I'm breaking the equations down without telling you where the household is and where the firm is, then I for sure have to do that. So just to be consistent with the textbook, this is going to be the output by the firm, but I don't really like putting the D on top. I'm just going to put the D here so that it wouldn't confuse you guys. So this is the output. This is how they produce. And as we know, the firm has a profit function. It's basically Y minus the cost. Because the firm produces using only the household labor supply, it basically has to pay the wage. That's the only thing that it has to pay. The wage multiplied by how much it gets in terms of the labor demand. We also know how it produces. So this guy is just going to be Z, U multiplied by the H of D. So this is going to be the profit function of the firm. And D here represent the fact that they demand the labor from the household, and the household supplies it to them. Now with this question, one thing you have to keep an eye on is the fact that this production function is linear, and this guy is also linear in H of D. Ideally, what you will have done here is differentiate your profit function with respect to H of D, because you are trying to maximize this function, knowing the amount of labor that you like to have, and equate it to 0. When you do that, you end up with Z U minus W U equals 0. This is not solvable in the first place because there is no H in the equation to clearly see what the value of H needs to be. So if you have a linear function like this, and you have a profit function that ends up being linear, then differentiating the equation is going to be very difficult. You wouldn't be able to find the best solution out by differentiating. What you would do here is to use a couple of conditions, see where the profit lies and all that. Is that okay for everyone? If you need further clarification on that, let me know. the reason why we can't use the differentiation to get the labor demand. Is that okay?
Like it's all good.
Good. So if you are to come across a question where there is maybe an alpha here, then you have to use the first order condition. But because this is linear, I'm not going to use the first order condition. So because this guy is linear, what we are supposed to do here, this becomes Z minus W U H of D. This is the profit function. The three conditions, just like what we saw in chapter 4, are going to be the situation where Z is greater than W, will imply that your profit is going to be positive. And if you have a positive profit, you will be tempted to hire more and more people. That's the first part. So with this condition, the amount of labor demand will be infinity. When you have a situation where Z is less than W, then your profit is going to be negative, and your H of D will just be 0. You wouldn't want to hire anyone because you don't have any profit. And the last condition, and that's a condition we mostly see in a comparative equilibrium on the comparative market where we set our profit to 0, which implies our Z is the same as our W. In that case, your H of D should be anywhere between 0 to infinity. Anything works. You can decide not to hire people. You can decide to hire people. You can decide to have half also. Everything works over there. So these are the three conditions that we should keep an eye on. 1, which is hiring infinity. 2, which means hire no one. And 3, which means employ anywhere from 0 to infinity. So this is a profit function by the firm. And this is the one that we are going to use. Is there anyone with any question in there?
No.
Okay. So if that's the case, we are done with the firm's decision. We know how the decision of the household looks like. And in comparative markets, as we said, the labor supply will be the same as labor demand, and that determines our wage, and everything is clearly solved. So let me clean this guy. Get down with the firm. Let's see how this guy looks like. So household, back to household. Remember the solution that we had was W was the same as Z. Household's decision-making process was the fact that they had a situation where they consume by using, I believe, W, which is the wage that they are being paid, U, which is the age of S, it's the labor supply. Is that okay with everyone? Questions?
Yes.
Is there a question in there?
Oh, no questions. It's good.
In the comparative equilibrium, we saw the labor supply being the same as labor demand. So H of S is the same as H of D. You might want to put a U here, you might want to put a U here. And to make life easier, because you have the same notation, this basically implies that we can give a usual H to the equation rather than saying that this is HS and this is HD. Provided we are in equilibrium, and then we have one single H to represent them both. And if that's the case, we probably have to also go back and see what the consumption decision of the household needs to be. So we saw from the firm's decision that this will be the wage, and which basically implies that I can replace the W with this guy here. So this is also just going to be Z. So there's a Z here, there's H here, and as we also pointed out, the same amount of labor supply will be a similar labor demand, which basically says that this guy can also be replaced by H. So you can do that as well if you're in the equilibrium situation. So the most important equation here is the H prime, which initially happens to be as a function of, happens to be S, B, 1 minus U, H, S. But because HS is the same as HT, which is the same as H, then I can take away this guy here. So this becomes an equation that will be of, significant importance to us. So we have how people accumulate their knowledge, and this will be the equation to better understand how it looks like. The question here is, how will the knowledge move, along time? With time, how is this knowledge acquisition process, how is it going to grow? So remember, the growth rate of anything is current minus the past divided by the past, which is the growth rate. So here, this guy is just the same as H prime minus H all over H, which is the same as H prime divided by H minus 1. Should give us the growth rate. So this guy here, I know that I can get the growth rate from this formula. So to make my life easier, I know that I just have to subtract this guy with a minus 1. So first of all, divide them with H. Divide this guy with H. Divide this guy with H. It's just the same thing. Subtract minus 1 from it. Minus 1. Minus 1. The outcome will just be the growth rate. Is there anyone with any question with this formulation? The outcome will just be the growth rate.
So can we cross out the H's on the top and bottom to simplify?
Yeah, we can do that easily, right? So we have this guy now becomes the growth rate of human capital accumulation. This we cannot take out, but this, as you guys pointed out, is just going to be B, 1 minus U. The H will cancel out, and I have minus 1. So this is a growth rate of human capital accumulation. So how we grow in this economy, how different is this 1 minus U from what we saw in Solo? Anyone to help me? How different is this 1 minus U from the one that we saw in Solo? What was the result in Solo? How we grow over time? Anyone?
It was exogenous.
Exactly, it's good. But what was the exogenous value that determined it? Yeah, exogenous, that was good. Exactly, the population growth. Yeah, correct. But here, it's not as exogenous as we saw in the Solo models. So here, what we realize is that the human capital accumulation depends on B, 1 minus U, and U. Now, let's quickly do one or two things and get back to the intuition here. So we know that this is how we grow from the endogenous growth model perspective. This is how the knowledge accumulation grows. So before I go ahead, let's see how our consumption grows, how our output grows, and all that. So remember, consumption was given to us as C equals, what was here? Was it Z, U, right? And H. Was it this? Was that consumption? Let me know if it's not the case. Is this consumption in the competitive market? Good. So if this is consumption, for me to see consumption growth, I put up a bar here. This is the same as Z. There's not going to be a bar on top of it. This is U. They are just given to us. Now there's going to be a bar here. For me to see consumption growth rate is C bar minus C all over C, which is the same as C bar minus 1. If you have to work this out, it just becomes Z U H bar minus Z U H all over H. Z U. This guy here becomes Z U H bar minus H all over Z U H. This cancels this. And this is the same as H bar over H minus 1, which is the same as what we saw earlier. B, 1 minus U minus 1. Do we get it? So the nature of our consumption growth now depends on the nature of the growth in our human capital accumulation. Is that okay with anyone? Anyone have any question in there?
No more questions.
No more questions. Good. So you can do the same exercise if you're interested in finding how output grows. Remember, in this economy, we assume we consume what we produce. There is no saving. So the same idea will give you the same result for output. So output has the same implication, consumption has the same implication, and everything now depends on the growth of B, 1 minus U, and minus 1. So there's not going to be our growth depending on N, just like what Alex pointed out earlier. Now, the good news here is if our growth is now dependent on B, 1 minus U, and minus 1, in a situation where our B is positive and greater than 1, then we find ourselves in a very good situation. And let me point out on the graph right away. So let's see this guy here. I'm going to draw this graph and I'm going to ask you guys a couple of questions before we complete it. So if I have a graph that looks like this, and this is a 45-degree line, what's the slope of this graph? What's the slope? If it's a 45-degree line, 1, correct. So the slope here is going to be 1. So if this is my current and this is my future, it's 1 because whenever I move this guy to this guy, it gives me the same thing. Here H bar is the same as H, and here H is the same as H bar. It's 1. It's a mirror image of itself, so the slope is going to be 1. So thanks, guys. Now, based on what we just saw, remember we saw that the H bar over H minus 1 is the same as, what was the slope again? B, 1 minus U minus 1. Was that the case? Ella, are you there?
Yes.
Good. So if this is the slope, my question here is, if B is greater than 1 and this guy here is greater than 1, what will be the slope of this graph? Will it be up or down? It will be up, right? So given that B is greater than 1, and the final equation is that, it's just going to be up, right? So this is going to be this slope when B is greater than 1. So there is no way that you become stagnated. And by that, I mean, when you have this blue line, for every H that you invest, the outcome is certainly going to be greater than what you have here, regardless of where you find yourself. There is nothing like a steady state. So far as you are increasing your H, the return is just going to be higher. And so far as the returns are going to be higher, things like your outputs, your consumptions are also going to be equally higher. So there's not going to be convergence in this respect. There's going to be divergence. Is that okay with everyone?
Yes.
So that's one thing we have to keep an eye on when we are trying to compare the solo model with the endogenous model in terms of the growth. One additional thing that I would like you guys to pay attention to is how these parameters tend to affect our decision making. So remember, we saw that B, what's the time, Ella?
It's 11:07.
11 what?
07.
07. Oh, okay, then we have some time there. One or two implications that we need to pay attention to is we had B, 1 minus U, determining how fast we grow. Either we grow at a faster rate or we grow at a much slower rate.
Quickly, Tanya's asking, so is there no steady state in this model?
No.
Okay.
There's not, because there's not going to be convergence. Steady state happens because you reach a point where you cannot go above or below. Whenever you go above it, you are being dragged back because of the diminishing marginal returns property. And by that, I mean this. Because of this diagram, this is said to be our steady state. It happens to be our steady state because as soon as we go past this level to a level like here, our returns happens to be pretty much marginal or constant. It doesn't change that much. While things like depreciation, growth rate eat into our investment. So we are constantly being dragged back, right? We are being dragged back to come back to this value. But for the endogenous model, the line doesn't look concave. It's not this concave. No, it's not going to be this concave. There's no concavity in there. So nobody is dragging you back. So far as your line is increasing at an increasing rate or at a constant rate, then you don't have... Is it okay?
Thanks. Yeah, that's good.
Okay, good. So one or two things that we need to keep an eye on is, remember your growth rate basically depends on this guy. So the first question here is, when you increase your U, what happens to your growth rate? When you increase your U, what happens to your growth rate? Anyone to help me? When U increases, what happens to the growth rate? It decreases, right? And what does it mean to say that you increase your U? Remember, your consumption comes from the fact that H, whilst your investment in human capital comes from the fact that you have 1 minus UH. So when you increase your U, it means you spend more time working, and less time in school. So whenever you live in a society where people spend more time working in order to feed themselves and lesser time in getting knowledge, then the implication here is that the growth rate is going to go down. So you increase your time working, less time in seeking knowledge. This guy goes up, this guy goes down. So there's going to be a trade-off. Provided we spend much time eating without working, then our growth rate is going to come down. Is that okay for everyone? Any question?
Yes, it looks good. No question.
Where the problem will come from is the fact that if we decide to do the opposite, right? Ask yourself the same question. If you decide to do the opposite, that is to say, decrease your consumption, what happens to your consumption at the end of the day? In the long run, what happens to your consumption when you decrease the amount of work time today? What happens to your consumption in the long run? What happens to G? Anyone to help me? What happens to your consumption what happens to C prime, the growth in your consumption, when you decreases? Anyone to help me? What happens to the growth in your consumption when you decreases? It increases, right? It increases. Because remember, C prime divided by C minus 1 is the same as the growth rate. The same as this guy. So if this guy is the same as B, 1 minus U minus 1, when U comes down, your consumption goes up. But there's going to be a trade-off. It doesn't go up right away. It goes up after some time, but today it will come down because of the fact that U happens to be a function here as well, your current consumption. So when you decrease your U, which means less work time, instantly your C comes down. But in the long run, or over time, the growth rate of your consumption goes up. So please keep an eye on that. That might be a bit confusing. And let me know if it is not clear. Draw my attention if it is not clear. And if you happen to be around, kindly type your name and present for the attendance. And after that, you can come in with your questions. Questions? Questions?
Could you repeat the last part again? The growth goes up, but it is delayed.
The growth goes up. Yeah, the growth rate of your consumption goes up, but in the current state. So when the whole idea here is that you have a decision to make today. You have a decision to go to school or a decision to go to work. If you decide to go to school, you don't work. And the fact that you don't work, you don't have anything to eat today. Or even if you have something to eat, it wouldn't be that much. Compared to your colleague who decided not to go to school today. He just went to his construction job or any job that he finds. He gets work, he feeds himself today. His consumption today is extremely high, whilst your consumption today is extremely low. However, because of returns to knowledge, for every hour that you spend in school, you have almost 3 times the return. So tomorrow, the guy who happened not to go to school will still go do the same job and will be paid the same amount of money. For you, because you've gone to school and acquired enough knowledge, the return on your school is extremely high. So as soon as you go to the job place, they are willing to pay you extremely higher. So your consumption tomorrow is going to be higher than your colleague who didn't go to school. Do you follow the logic? Do we follow the logic?
Yes, that was, yeah, all good.
So, yeah, go ahead. Yeah.
No, that was it.
Yeah. So the idea here is, if I'm to ask what happens to consumption, the rate of growth in consumption over time when U happens to go down, you might be tempted to point out to me that the consumption rate goes up, which is absolutely perfect. However, should a student come in and explain to me that, hey, I know it's going to increase over time. However, in the current state, which happens to be this equation, the current consumption will have to come down. Then the person will get the perfect mark. Questions? Questions? Do you have any questions?
No questions. No more questions.
And again,
so you would have to discuss both sides.
Exactly. Yeah, you would have to. You are compelled to explain further. But you wouldn't be compelled to explain further if I ask what happens when B is to change. What happens when B is to change? There, you don't necessarily know what happens to C because B is not a direct function of the current state of your consumption. So when I say B, what happens when B increases? You can just say consumption increases over time. You don't necessarily have to come in and explain to me that current consumption goes up or down because current consumption is not a function of B. So you're not obliged to say that. Right? Is that okay with everyone?
Sounds good.
Yeah. Unless, of course, I go a step further to say, hey, what happens when B is a function of maybe Z or is a function of maybe U or something like that? Then you have to come and explain further. So an example being, imagine I give you guys a function of B that's a function of U. And then you have extra trouble explaining. Yeah. Yeah.
Can you explain the part about what happens when U increases?
Can I, sorry, the question again, there was a break in there. Can I explain what happens when?
U increases.
When U increases. So when U increases, today's consumption goes up, right? You decided to give enough time to work so that you can consume as much as you can. Look at this equation. The growth rate of your consumption over time wouldn't be increasing. It will rather reduce because this guy is a function of you. To calm down. You have the instant pleasure of having enough consumption today, but there's going to be a trade-off over time.
Okay, thank you.
Yeah, sure. Questions, guys? Questions? Feel free. If you have to read the book and you find something that is confusing, and if you need any further clarification, just draw my attention. So let me see what we have here. Good, we have about 5 minutes to finish. So this will be a good time to stop and take a review of what we did for the past, I believe, 5 weeks. If you have questions on the midterm, feel free to ask me for the next 6 minutes. If you have questions about how you want us to proceed for the second part of the course, please let me know. You can point it out, what you think we can change and what you think we can improve. Feel free to make the points known. And if you have any additional questions, feel free to ask. So we have an open house. Ask questions as you deem fit. Midterm, course material, what should change, what should be included, and all that. I'm going to be here for the next 5 minutes.
Will Tuesday's class be reviewed?
That Tuesday will be a review. Yeah.
Will we get a midterm review or like practice questions for the midterm?
Yes, I said this is my first time teaching, so I don't necessarily have enough material on the course, like practice midterm and all that. And I pointed out that I'm just going to make it class related. So questions that are related to what we did in class. So if you have to pay attention to the lecture video and then the questions that you guys, answered just like what you saw in quiz 2, then that's going to be the nature of the questions. Yeah.
Okay. And will the two-sided search model be in the midterm as well?
It's part of the material, so it's open to it. Yeah.
Okay.
questions?
Will there be multiple choice or short answer?
I don't know for sure because my experience with the first midterm was that maybe some of you might have wasted much time reading all the multiple choice possible answers, and it might have ate too much into your time. So I'm a bit, I don't know. I don't know for sure whether I'm going to bring the multiple choice, and if I'm to bring it, how many should it be?
Mm-hmm.
I don't, just be open to them.
Okay. And then will it be on Canvas, the midterm?
Yeah, it's going to be on Canvas, and you don't have an opportunity to go back and change your questions. As soon as you're done submitting, then you submit it, you go to the next question. And this is to prevent, as I pointed out earlier, cheating. So if I enable multiple return to one question, I don't know how people might try to collaborate and get it solved. So everyone will be under pressure to answer his or her question. The time is going to be limited. And as soon as you answer, you go to the next one. There's no to limit collaboration between students. So that's been the advice, and we need to stick to it.
Okay. I think that's all the questions right now.
Tanya had a question?
We have, yeah. When the solo model has different N, S, Z, or D, the rich and poor countries don't meet at the same spot because they'll have different steady state points, correct? But in the endogenous model, the rich and poor would be on the same line, but would never meet at the same spot, right?
Okay. For the endogenous model, as soon as I take the lead, right? Okay. Whilst for the solo model, if I make an assumption that everything is the same for the rich and poor, then the poor will catch up with the rich. But as soon as I change an assumption that one of the factors between the rich and then the poor are not the same, then there might be difference between the rich and then the poor, even under the solo model. Okay. Is that okay?
And then, yes, Tanya says that's good. And then there's one more question about the midterm. So will it be like a file we print out and then upload to Canvas, like the testing we did today?
Yeah, that's what I wanted to, find out in terms of whether I might be bringing equations in there and how quickly you guys can get it uploaded. So that's what I tried doing today, and the response has been good. So I'll obviously consider that, see how you guys can get it.
Okay. Do we need to turn on our camera during the exam?
I should be, we've been advised to use Zoom for proctoring, as in we can use Zoom. So I think if the opportunity presents itself, I might ask a couple of you at random to make yourself available, but I don't know how it's going to be. I might have to talk to the department first. Yeah.
Okay. And the file format, can we do PDF or JPEG or?
Yeah, I'll go through what you guys posted today. If I happen to find problem with the file that you sent, I'll make it known to you right away, right? So I will just comment.
Okay.
Yeah.
Mm-hmm. And then John asked, I think someone might have already asked this, but the material will focus on the examples discussed in lecture.
Yeah.
Yep. And then how many questions approximately in total?
I'm planning as much as I can, one or two from each section. And I think we have like 5 or 6 sections or so.
Okay.
Yeah.
And it said late when I uploaded the present file. Can you give us 10 minutes instead of 5 to upload?
Oh yeah, feel free. For today's assignment in terms of posting it, I was just trying to see how it works. But for Thursday, just keep an eye on it. If you had issues today, just try as much as possible to work around it, right? In terms of the comment that I'll be sending out, whether I receive your file or I didn't receive it, or whether I think your file is too big, it's not readable, and what's not. So I'll make the comments known to you and just have to work around it. Is that okay?
Yeah, that's good. That looks like all the questions right now.
Okay. So so hopefully Tuesday we'll meet. We discuss what your issues might be in terms of the topics. Then Thursday we have it sorted out. So you guys, you shouldn't be worried too much. As I said, there's no need to go in for someone to help you out. No, I'm not going to make it extremely hard. I'm very much interested in the intuition and how you guys
understand each and every step in terms of getting the equations, how you guys understand how the parameters do change the results and the intuition behind it. If you understand it, then it should be fine. Okay, then. See you guys on Tuesday, hopefully.
Okay, thank you.
Oh, all the best. Bye.